All right, now example 3 asks us to identify the vertical asymptotes, but I'm actually going to also add in, also find the holes, just so you can practice. So find the vertical asymptotes and put and holes of the graph. Okay. Just like the bell ringer. So in example A, can I simplify at all? No. So that means I'm not going to have any holes. If you want, you can write no holes. On your quiz, it'll say holes with a little line. You can write none. How do I identify what the vertical asymptotes are? The denominator. The denominator. Remember, the numerator is not needed for asymptotes at all right now. It'll be used for horizontal, but not for our vertical. So we're going to take the denominator for VA. We're going to take the denominator, set it equal to 0 to find this. So our denominator has 2 pieces, so you want to set each one equal to 0. Separately. Most of you just do this in your head, I think. Subtract 1, you get x equals -1. That's one of our vertical asymptotes. And subtract 3, x equals -3. Now, could you also type this in your graphing calculator to look at it? Sure. But if you're going to type it in the graphing calculator, you would need an extra set of parentheses.
Wouldn't that be x minus 1 equals 0?
Oh, sorry, I copied it wrong.
There you go.
I copied +1. And then that would be plus. Thank you. And the other one's right. Just a copy. Like some of you guys do on your quizzes. And then kick yourself out.
Wow. Yeah.
We're all human. We're all human. All right, can we cancel anything in the next one?
Yeah.
Uh-oh. When that simplifies, what is the simplified equation? Y equals? Cohen?
1 over x plus 3.
Perfect. 1 over x plus 3. Because this was in the denominator, it can't just magically move to the numerator unless it had a -1 exponent. Then it could move, but it won't. Table. Yes. Here's your homework. All right, so because we crossed these off, that means that we will have a hole at x minus 2 equals 0. Add 2 to both sides, so that would be 2, comma what? 1/5. 2 plus 3 is 5. 1 divided by 5 is 1/5. And then what is our vertical asymptote going to be? Jeremy? X equals -3. Perfect. Try example C on your own.
Yeah.
All right, who can tell me what our hole is? Do we have a hole?
C.
Someone I haven't heard from yet today, please. Bailey. -1, -2. Because we factored our numerator into x plus 1, x minus 1, and these divided out. Very good. Vertical asymptotes. Parker.
Why is it -2?
What, when you take the x value and plug it back in,
I plugged it in wrong.
-1 minus 1
Yeah, I
is
plugged it into the x.
the one that you got rid of. Is there a vertical asymptote? No, you're not left with the denominator at all, so just say no VA. So if this one will graph as a line, everyone,
It's just a
it'll have a hole in the line when you're graphing. All right, now our new piece of information today is the horizontal asymptote. Now you need to be careful because before the horizontal asymptote equation was y equals k. Remember that?
good.
However, that only worked, and let's jot that down. It'll be y equals k only if the equation is in the form y equals a over x minus h plus k. So if there's like an x squared in the equation, or there's an x in the top, you can't use y equals k because there's no k. There's no general form for a polynomial equation. So if it's like that, you can just tell me y equals k. You're done. But that's not going to be the case for the polynomial functions that we see today. So to find the horizontal asymptotes today, obviously you can always use your graphing calculator and look, okay? But sometimes it's hard to tell if it's not a whole number. So you will actually compare, which means greater than, less than, or equal to, the degree of the numerator to the degree of the denominator. Who remembers how you find the degree of a polynomial? So for example, what is the degree of that polynomial? The degree helped us to name it.
Cubic.
It is cubic, but the degree would be just 3. Okay? It is a cubic trinomial, but the only part you need to worry about is the largest exponent is the degree. Usually if it's in standard form, it'll be the first exponent, but if it's not in standard form, you have to look for the largest exponent, that's the degree. So you're going to compare the degree of the numerator to the degree of the denominator, and depending on which inequality symbol you use, that will tell you what type of asymptote you have, horizontal. So it says if the numerator is less than the denominator, this is the degree of the numerator, is less than the degree of the denominator. So for example, x plus 1 over x squared minus 1. So the degree of the numerator is 1. The degree of the denominator is 2. So that would be 1 is less than 2. The horizontal asymptote will be y equals 0 all the time. Don't need to memorize this chart. If it's the other way around, if the numerator degree is bigger than the denominator degree, so let's just switch those around. X squared minus 1 over x plus 1. You will have no horizontal asymptote because the numerator degree is 2, the denominator degree is 1. So if the numerator degree is bigger than the denominator, no horizontal asymptote, which if you go back to our last example, that's what we got, right? We had, well, that was a vertical asymptote, never mind. That also will fall for horizontal too. This one that we just did, when those canceled out, you end up getting a line, so it doesn't have a horizontal asymptote, it just has a hole. And lastly, if the degree are equal, so for example, 2x squared plus 3 over 3x squared minus 1. If the degrees are exactly the same, 2 and 2, then the equation is y equals an a over b. These stand for the coefficients. So those would be the number in front of the variable with the degree. So the coefficients would be 2 and 3. So the asymptote would be y equals 2/3. So that'll be a horizontal line at 2/3. So every time I ask you for the horizontal asymptote of a polynomial numerator and denominator, rational function, you need to compare the degree by looking at the largest exponent. Based on which one you pick, you'll identify the asymptote. So you need to memorize this chart. Hopefully by the end of your homework tonight, you'll have it memorized. But we'll see. So A, B, and C just asked us to find just the horizontal asymptote. Eventually you're going to have to do all the asymptotes and all the holes and x-intercepts and y-intercepts. But, so if it's horizontal, you do not have to factor. You can if you want to, but you don't have to. We just have to compare the degrees. So what is the degree of the numerator? 1. It's 1. What's the degree of the denominator? 1. So the degrees are equal. N equals D. The numerator degree equals the denominator degree. So we use the coefficients. This will be y equals a divided by b. Again, a is the coefficient of the numerator, b is the coefficient of the denominator. Simplify that and we'll get -4. That's the horizontal asymptote. We would draw a horizontal dashed line at -4. All right, and the next one, what's the degree of the numerator? 1. What's the degree of the denominator? 2. So the numerator is less than the denominator. It will always be at y equals 0. The last one is obviously the third type. The degree of the numerator is 2. The denominator is 1, so that means the numerator degree is bigger than the denominator. That means there are no horizontal asymptotes. All right, in the back we're going to, and these are what your test questions will kind of be like, they'll say graph, and then they want you to identify a whole bunch of stuff. Actually, these ones just say graph. We could add in all of the parts if you want, because your quiz will say find the horizontal asymptote, vertical asymptote, holes, x-intercept, y-intercept. I don't think I asked for domain because you guys all get that right. You probably would have liked to point to that, but.
We're running low on time.
Hmm?
We're running low on time. Maybe we should
Oh, we have
do
plenty of
graph.
time. We have 11 minutes. Are you kidding? All right, what do you want to find first, the vertical asymptote or the horizontal asymptote? Cohen spoke up first, vertical. So to find the vertical asymptote, we need to factor from yesterday. Factor the denominator, what do we get? I don't. You can run to the restroom. Sorry. What would the denominator factor into? Savannah? X minus 2, x plus 3. The numerator cannot factor at all. Can we cancel anything? Divide out your x plus 3's. Now, because I canceled something out, what do those represent? What I canceled, what does that represent? Hayden? A hole. So let's add that. There's going to be a hole at -3. -3 comma what? Well, let's find out. Plug it back in. -3 minus 2 is -5, so that would be -1/5. Okay. Now back to the vertical asymptote. That's the part that's left. X minus 2 equals 0, so the vertical asymptote is at x equals 2. And you can plot these as you go, or you can wait till the end. We also need our horizontal asymptote, which is what we've just learned. For these, you have to compare the degree. So the numerator has a degree of 1. The denominator has a degree of 2. So what is our horizontal asymptote? Sam? Y equals 0. The numerator is less than the denominator, so y equals 0. And we got our holes and our vertical asymptotes. Do you want to find the x and y intercepts too? Because you're going to have to do that on your quiz. Let's do it.
I already did.
Remember, it's just plugging 0 in for the other letter. So the x-intercept is when y is 0. The y-intercept is when x is 0. So the y-intercept is the easy one. Let's do that first. You plug in 0 for x. 0 minus 2 is -2, so that'll be -1/2. My x-intercept is when y is 0. So plug that in on the other side. And we'll have 0 equals 1 over x minus 2. Undo division with multiplication, and then we should get none for this one. Because 0 times anything is 0, and 0 doesn't equal 1. So let me get rid of what I wrote here. There is no x-intercept. And that should make sense to you because there's a horizontal asymptote at y equals 0, which is the x-axis. So it shouldn't ever touch there. All right, so let's go ahead about graphing this. Vertical is at x equals 2. Hole at -3. -1/5, which will be an estimate, of course, and a horizontal asymptote at 0. And then definitely use your graphing calculator to assist you in your table / connecting and sketching. So you need to use parentheses. Always graph the original. And then usually I pick a few points before I sketch my graph. And you will see errors exactly where you want to see them. I could have plotted my intercept. 0, -1/2. That was a point I had already over here. 1, -1. 3, +1. And 4.5. That's probably enough to get, as they say, wing it. A lot of students are saying, I just kind of wing it with my graphing calculator. I'm like, that's fine. As long as you have your asymptotes drawn and your holes drawn, then you can use your calculator to wing it, assuming you type it in the calculator, right? Very important. All right, I'd like you guys to try, well, I'll get you started on number 6, because there is something weird about factoring it, and then I'll let you finish it. So in the top, see how the number and the variable are not in their normal location? You want to rearrange those first. It cannot become x minus 2. It would become -x plus 2. And then you can factor out a -1, which will get you x minus 2 in the top. That's the only hint I wanted to give you. I want you to finish the problem, factor the denominator, find out what the vertical asymptote is, the horizontal asymptote, if there's any holes, find the x-intercept, the y-intercept, and graph. And then do make sure, guys, that I do clearly see your hole. Make sure that you have an open circle.